In the next few moments, I want to highlight how simple it is to use this NASTRAN optimization web app to create Solution 200 BDF files. For this, I'm going to use the very familiar 3-bar truss example that you'll find in the optimization user's guide. So let's go ahead and start off where a typical user would start off. A user would start off with the Solution 101 or any 100 series BDF file that he may have created in Patran or some other pre-post processor. So let's go ahead and copy all of this and paste this into our web application. This web app will do two things. One, it will convert the 101 file to a Solution 200 file. And the second thing it would do, it will help you generate the bulk data entries for your design variables, your design objective, and your design constraints. So now let's go ahead and take a look at what the process is like. Here I pasted my original BDF file, and it's actually gone ahead and identified all the entries that can be set as design variables. For this example, I'm interested in setting the 3 areas as design variables so I can select these plus icons to reserve them as design variables. Here in this next table, I have my design variables listed. This is where I can modify the lower and upper bounds for the design variables. As an example, my cross-section area is allowed to range between 0.01 and 100. And keep very close attention to the right hand side. This is where you have your bulk data entries generated. What's really great about this, the update happens instantaneously. So when I make an update here on the left, it's immediately visible here on the right. So here you can see I typed in 999 and it was immediately updated. Let me go ahead and remove that. And here on the right, the update happens. Let me go ahead and copy these lower and upper bounds to the other boxes. And as the example states, I want to link two of the design variables together. For that, let's go ahead and create a link. We'll say that design variable x1 is equal to design variable x3. And as I said before, when you make an adjustment on the left, the output on the right is updated. One thing I'll point out are the labels. The labels are used throughout the web application, whether you're creating an equation, whether you're creating a constraint group, and here I'll show you more of that in a moment. Let's go ahead and create our objective. Here we have a long list of response types we can set as objectives. Here we want to set the weight as the objective, and of course I want to minimize the weight. Let's move on to constraints. I'm going to create 2 constraint types, one for displacement and one for stress. We are going to say that the displacement at grid 4 for the x and y direction, or the 1 and 2 direction, is allowed to go between negative 0.2 and positive 0.2. As for our stress, we are going to say that for P rods 11, 12, and 13, it can range from negative 15,000 to 20,000. And then for the stress item code, we will use 2. And now we get to create our constraint group. We can do this manually. So let's go ahead and create a constraint group. And again, the labels are what make this really simple and straightforward in the application. I can type in R1 for constraint 1 and R2 for constraint 2. And then the necessary decon add entry is created here on the right. And of course, I want to apply this to all the subcases, so I'll go ahead and set this to all subcases. And now that completes the creation of the design variables, objective, and constraints. Let's go and look at our exporter. Here on the left is the converted original BDF file. You'll see that it now says Solution 200. It includes statements for the objective, the constraint, and the analysis type. Again, this application does two things. It will, one, convert your original PDF file to Solution 200, and number two, it will help you generate the necessary entries for your design variables, your objective, and your constraints. And now that we're complete with both of these things, let's go ahead and download these two PDF files. And those were downloaded to my downloads directory. And now I can run NASTRAN and perform my optimization. And this is just to really finish and communicate the point that this app makes the process really simple. We'll go ahead and look at the F06 file and make sure we got the same solution as the example from the user manual 2.69. Perfect. So this is the same solution from the book. And at this point, a user could take his results and manipulate them as the normal procedure specifies. Here I can open up the CSV file and analogously post-process my results. Here I'll go ahead and take these CSV results and paste them into my template here. I can do things such as manipulate the design variables, suppress some of the visibility, and so on and so on. So a few additional comments regarding this web app. Again, this web app is meant to make the process of optimization or size optimization a lot simpler. Let's suppose that weeks or months in the future you have a design model that you wish to modify. Let's go ahead and look at what the process looks for that. So here is my old PDF file from, say, a month ago, and I want to augment some of the objective as an example. Let's go ahead and copy everything in our design model and go to the importer. We'll paste the text there. And what this will do, it will import your design model entries to the web app. So now we have entries for the design variables. These are the same ones we specified, say, a few weeks ago. We have entries for the objective and the constraints. So this allows you, or rather, this is a saving capability, if you will. And the last thing I want to leave you off with is a comment regarding the labels. The labels are very, or rather, they make the process of using constraint groups and equations very simple. Here is an example. Let's suppose instead of using this objective, we want to create a custom objective that is specified by a equation. Or rather than that, let's go ahead and demonstrate this with the constraint. If I scroll to the bottom, there is a special section for synthetic constraints, as I call them. This is where you can type in an equation that defines the constraint. What I can do here is use the labels that I find out throughout the application to create my synthetic constraint. Here's an R1 and R2 for these two constraints. Here's an X1, X2, X3 for these three constraints. Let's go ahead and use these labels for our new synthetic constraint. Here, for example, X1 plus X2 plus X3 plus R1 divided by 2.0 plus R2 times or squared. And then we'll include upper bound. Here on the right, you can see what's happened. It's created the necessary DRFs2 entry. It's created the necessary D equation entry. Here you can see the same string of the equation here on the right and the left. And it's created the necessary D constraint with the upper bound that we just created here. And then for our D conad group, we can update it with the label capital R1, which is located in the column label. And the deconad entry is updated with the new ID for the synthetic constraint. So that is the last thing I wanted to leave you off with, which was the use of the labels to update equations and constraint groups. At this point, hopefully you found how simple it is to use the web application to create your NASTRAN Solution 200 design models. Thank you for watching.